block diagram, we discussed the pin diagram. This is the pin diagram. IC pin diagram of op-amp. Can one of you read the pin names, pin description of the pins 1 to 7? Can anybody among you read the pin description? Yes. Anji. Can you read the pin numbers? One of you can read the pin numbers of this. Are you hearing me properly? Yes, students.
Yes,
so can you read out? क्या नाम है बेटा आपका?
Lular.
Lular, can you read pin number 1, 2, 3, 4? Just read out the names.
Sir, 1 offset null adjustment, 2
Okay.
inverting input, 3 non-inverting input, 4
Okay.
negative bias supplies,
Okay.
5th offset null adjustment, 6
Okay.
output, 7 positive bias supply, 8 not connected.
Fine. So can you tell me now what is the role of inverting input here?
सर इन्वर्टिंग इनपुट पे जैसे कोई देते हैं तो उसमें फेज चेंज हो जाता है पाई डिग्री से और एम्पलीफाई हो जाता है।
एग्जैक्टली। तो इन्वर्टिंग इनपुट पे जब हम ऐसी सिग्नल देंगे तो पिन नंबर 6 पे एम्पलीफाइड और फेज शिफ्टेड सिग्नल हमें मिलेगी, राइट?
यस सर।
और इसके अपोजिट अगर अब हम पिन नंबर 1 पे, अगर हम पिन नंबर 3 पे अब ये सिग्नल अप्लाई करते हैं तो 6 पे कैसा सिग्नल आएगा? एम्पलीफाइड, बट इट विल नॉट बी फेज शिफ्टेड, राइट? हैव अदर्स अंडरस्टूड? बाकी बच्चों को समझ आ गया? तो इस तरह से जो है दिस इज द रोल ऑफ इन्वर्टिंग एंड नॉन इन्वर्टिंग पिंस। और आपको मैंने बताया था इसका ब्लॉक जो इक्विवेलेंट सर्किट है वो कुछ ऐसे हम बना सकते हैं। ये देखिए, दिस इज द आईसी equivalent representation or equivalent circuit diagram for IC 741, right? So if I draw this diagram, how does this diagram look like? We can draw this diagram in this manner. See, I'm drawing it here. From the input side, we can draw it in this manner. This is the inverting terminal, pin number 2. Between inverting and non-inverting, we assume that there is an input impedance which is represented by Zi. So inverting terminal is represented by minus, non-inverting terminal is represented by a plus sign. Terminal number of non-inverting pin is pin number 3. And on the output side, we have a dependent voltage source. So this dependent voltage source looks like this, as you can see here. It looks like this. We assume that there is an output voltage source which looks like this. So between the voltage source and the output, there is an output resistance R0. So here we get the output V0. If you look at this previous representation, we have modified it further. We went one step further with this. And this is output resistance, this is input resistance Ri. Ri can be taken as Zi, where Zi is the input impedance of the device, right? And R0 can be taken as Z0, and this is called as output impedance of the device. If you remember yesterday in the classroom, I told you certain facts about input impedance. What should be the ideal value of input impedance? Should it be high or low? Zi or Ri? Lular, what is the answer to this question? आप नहीं थे. Who was present yesterday in the classroom?
Sir, high होनी चाहिए.
हाई होनी चाहिए बेटा। क्या नाम है बेटा आपका?
देवांशी।
प्लीज स्पीक अ बिट लाउडर।
देवांशी।
हाँ तो बेटा आप ये बताओ हाई क्यों होना चाहिए? आपको हाई मैंने बोला था कल, रीजन इसका बताया था दैट इनपुट इम्पीडेंस शुड बी वेरी हाई, इट शुड बी एज हाई एज पॉसिबल। व्हाट वाज द एक्सप्लेनेशन आई गेव फॉर दैट?
सर जैसे कि जितनी इनपुट वोल्टेज हम दे रहे हैं एज इट इज हमें आउटपुट में मिल सके, रिड्यूस होके ना मिले।
ओके, दैट इज द राइट आंसर। सो इनपुट इम्पीडेंस जितना हाई होगा उतना ही हमारी इनपुट वोल्टेज जो है, अगर लो वोल्टेज सोर्स हम यहाँ पे कनेक्ट करते हैं, अगर हम यहाँ पे बहुत ही लो वैल्यू का वोल्टेज सोर्स कनेक्ट कर लेते हैं जिसका वैल्यू मिलीवोल्ट्स में है, so that entire voltage will come here if Ri is very high, because you know the basics of a circuit. If I have a voltage source of 10 volts, say 10 volts, and if I connect this voltage source to an open circuit, what will be the voltage here at this point? What will be the V naught? V naught will be 10 volts because it is an open circuit, right? So open circuit or very high resistance means the same thing, right? So this is the model of an op-amp, how op-amp looks like, and the voltage at the nodes is expressed as, this is expressed as V2, this is called as inverting node, this is V1, this is called as non-inverting node, right? So these are the two nodes or two input terminals which are marked as input 2 and input 3. The name of the voltage source is AV into VID. Now what you will be wondering, what is VID? VID is the difference between voltages of inverting and non-inverting terminal, V1 minus V2. This is called as differential input voltage. So if you write down the equation of V naught as the output voltage, it can be written as A times V1 minus V2, or it can be written as A times VID, where VID is the, this is called as differential input voltage. Differential input voltage, and A is the open loop gain. And this open loop gain is very high for an op-amp. It is of the order of 2 into 10 to the power 5 volts per volts. Right, so what we have drawn is the internal representation or internal block representation of an op-amp IC741. Apart from this, we will now discuss the basic representation of an op-amp. What are the internal stages in an op-amp, right? So if we look at an typical op-amp IC741 block diagram, it primarily comprises of 4 blocks. The first block, which is also called as the input block, this is the input block, input stage. Second stage is the intermediate stage. The third stage is a level shifting stage, and the fourth stage is called as the output stage. Now we will describe each stage one by one. So if you look at the input side, the input side includes 2 inputs, non-inverting input, which is terminal number 2, and inverting input, which is terminal number 3. This is applied to the first stage. The first stage is a dual input balanced output differential amplifier. So why do we call it differential amplifier? Anybody can answer this question looking into the previous equation that we have derived. If you look at the previous equation, if you look at this equation, the output is equal to gain times difference of the input voltages. So it is unlike other amplifiers where we directly apply input and directly get output. In this case, we first of all take the difference of the input voltages. That means the voltages which are applied at the inverting and non-inverting terminal, the difference of these voltages occurs at the input side, and this goes into the amplifier. Then the output produced by the amplifier is equal to A times VID. What is VID? VID stands for differential input voltage. That means this amplifier amplifies the difference of the input voltages. That is why op-amp is also called as a differential amplifier. We sometimes call it as a differential amplifier. Right? So we call it dual input balanced output differential amplifier. So if you look at the internal circuitry of this, it looks like this, with two transistors symmetrically placed. They are facing each other. This is how the circuit looks from inside. You don't need to go that deep into the configuration. When we will deal with unit 3, which is differential amplifiers, in that case we will discuss this circuit in details. So this is how the circuit looks like. Here is minus VEE, terminal number 4. This is plus VCC on the upper side, which is terminal number 7. This is terminal number 2. This is terminal number 3. This is collector resistance of transistor 1, collector resistance of transistor 2, emitter resistance of the common resistance, which is parallel combination of these two transistors. So this is called as, if we take output from the two collectors, then this type of output is called as a balanced output. So that means if the output is derived from both the collectors, that is collector C1 and collector C2. Are you understanding this? If we derive the output from both the collectors, then the output so obtained is known as a balanced output. And this configuration is called as dual input. Why dual input? Because in this case we are applying two inputs from terminal 2 as well as from terminal 3. So that is why we call it as dual input. And the second term that we associate with this is balanced output. What is a balanced output? I have just now mentioned. Balanced output signifies the output which is derived when both collectors are taken into consideration. So if we take both collectors into consideration, then this type of configuration is called as dual input, balanced output, differential amplifier. We are approaching the end of this class. I've downloaded your attendance. Let me see. So we will continue with the remaining portion tomorrow onwards. Have you understood what we have done so far?
Yes, sir.
Okay, so I will be providing you notes for this lecture as well as further lectures, and you can take out your book. As I told you yesterday, you can start reading the basics of op-amp. What is an op-amp? What all an op-amp can do? What is the caliber of an op-amp? All these things you can work out. And the notes that I am supplementing you, they are offered in question answer format, which is suitable for examinations as well. Right? So if you have any doubts, I want you to interact. Since we are again forced into an online interaction, I would have preferred that we are offline, and that was more resourceful and efficient method. But since now, because of the conditions that are generating, we have to again switch over to online mode. So we don't have any other medium other than this at this point of time. So you can utilize it well. I'll give you the notes and other things, and whatever doubts you have creeping in your mind, you can discuss and write them on a piece of paper and discuss tomorrow with me.